Hi, today we're going to talk about continents on the move. We're first going to start talking about tectonic plates. Tectonic plates are the large slabs of lithosphere that move around on the asthenosphere. Now these plates move so slow that you generally can't see or feel them moving. They only move a couple centimeters a year. Now if you took a ruler and measured out a couple centimeters, you'd understand how short of a distance that really is. And so you would understand how slow that movement is, and generally why you would not be able to feel or see these plates moving. Now there are different reasons they move. It could be because of the shape or the general way they interact with the other plates around them. But these interactions and these reasons don't really cause a major movement, so they're going to move very, very slowly. Now, where two plates come together and meet, that's called the plate boundary. These plates do not move smoothly along the boundary. They kind of rub against each other, and they cause a lot of pressure when the rock's edges and the plate's edges when they're rubbing against each other. Now, one way that you would feel the plates moving is when enough pressure builds up that an earthquake occurs. Now, earthquake, as we all know, is very devastating, but this is one way in which these plates put so much pressure that they cause a major pressure buildup, and they move, they shift, and this causes an earthquake. And this is when you will feel these plates moving. Now, one way that we can, even though we can't see them moving over time, scientists can measure the movement of the plates through the usage of GPS, or global positioning systems. Now, what a GPS system will do is it'll mark a certain area, like say at the office or a location where these scientists are working. They may mark a certain part of their building, and over time, months or a year later, they may check that spot again, and they'll notice that there will be a little bit of a difference in distance between where it was when they first started and where that mark is now currently on the GPS system. Now these satellites are up in space, so they're keeping track, so they're active, and they are accurate as far as where they can pinpoint where exactly you are on Earth. Just like we use GPS systems in our cars. As you're driving down the road in your car, a GPS system would probably be able to tell you exactly where you are on a certain road, and that's how we find that's what we use GPS systems to find directions and to find out where we are in our city, or where we currently are, or what road we're on. So they use these GPS systems to mark, and then they can figure out the distance and how far it moved, and then they can use that to determine how fast it moved and what's going on with those plates. Now, tectonic plates fit together like a piece of a puzzle. You can kind of use it like a jigsaw. Like if you have a jigsaw puzzle, you can kind of use that as an example. When you take a jigsaw puzzle, their pieces are all made to fit, or there's pieces that are made to fit together. Now, not all pieces fit together, but there are certain pieces that you know that will fit together. Just like tectonic plates, they're going to fit in a certain area, or against each other. Now, if you look at this diagram, you can see that the different plates, the African plate, North American plate, Pacific plate, and so on. Now, some of them, like the Cocos plate, which is right here in the middle, right below North America, you'll notice that one has nothing but oceanic crust. Now, some other ones, like the North American plate, will have oceanic and continental crust. So not every plate is completely just oceanic or completely just continental crust. Some of them may have both. So you can see where the plates are moving, and you can see if they have continental, or if they're just oceanic, or just or have both those types of crust found on those plates. Now, the changing Earth. Our Earth is constantly changing, even though we're not seeing it. But over millions of years from now, if we were to record where we are now on Earth in about 100 million years from now, see where we are, we're going to be in totally different locations. Now, when Earth was first formed, the Earth was one big continent called a supercontinent. This supercontinent is called what scientists call Pangea. Now, scientists believe because of what is called a supercontinent cycle, that millions of years in the future, our continents today will move back together to make a supercontinent again, like Pangea was at first. So over time, that supercontinent that was one big continent, the plates have shifted and moved, and that's how we've gotten so spaced apart from each other to where we are currently today. And scientists believe because of that cycle, we are going to eventually come back to where we began, which will be one big supercontinent like Pangea.